Welcome to Mr. Math Monster.
The standard form of a quadratic equation is used to find the equation from a table of values. This form of quadratic equation is ax squared plus bx plus c. The a coefficient determines the width of the parabola, with a larger value of a causing the parabola to be more narrow and a smaller value causing the graph to be wider. However, if the a coefficient is negative, then the parabola is flipped upside down. C determines the vertical shift of the entire parabola.
The factorized form, also known as the x-intercept form, is used when finding the equation of a parabola from a graph. It is often written as y equals to a times brackets x minus o brackets times brackets x minus p brackets, where o and p are the two x-intercepts.
The vertex form of a quadratic function is useful when finding the vertex of a parabola. The vertex form is y equals a times x minus h squared plus k, where h is the x-coordinate and k is the y-coordinate of the vertex.
Now let's look at an example.
The first step to finding the equation of a quadratic function is to find the second difference. If the second difference is constant, the function is quadratic. We will use standard form to find the equation of the quadratic function. First, we'll find a. A is simply half the second difference. In this case, the second difference is 2, so a is 1. C is the zeroth term of the quadratic function. In this case, the zeroth term is negative 4. To find b, we plug a set of values into the equation and solve for b. After plugging in x equals 1 and y equals to negative 3, we'll find that b is equal to 1. Therefore, the final equation is y equals x squared plus x minus 4.
To find the equation of this parabola, there are two ways.
From this graph, we can see that the two x-intercept points. These points are negative 2, 0, and 2, 0. This gives us y equals a times brackets x plus 2 times brackets x minus 2 brackets. Because when y equals 0, that means the x has to be either negative 2 or 2. Then, to find the coefficient a, plug in a point on the parabola. Let's take 1, negative 3. Insert the x and y values of the point into the equation. After this step, we can obtain the a, which is 1. Finally, this gives us the final equation in factorized form. Y equals brackets x plus 2 brackets times brackets x minus 2 brackets.
Finding this parabola in vertex form is convenient in this situation as the coordinates of the vertex is known. As we can see on the graph, the coordinates of the vertex is 0, negative 4. We can insert the x and y coordinates of the vertex into the equation as h and k.
From this, we get the equation y equals x to the power of 2 minus 4.
To convert between the standard form and factorized form, we will simply factorize or expand the equation.
To convert standard form to vertex form, we will need to complete the square. The standard form is expressed as y equals ax squared plus bx plus c, and we'll first need to divide ax squared plus bx by a, which gives us a multiplied by x squared plus bx divided by a plus c. Then we divide the coefficient of x by 2, which is b divided by 2a, and minus the squared divided number, which is b divided by 2a squared, which gives us a times brackets x plus b divided by 2a brackets squared minus b divided by 2a squared plus c.
For example, to convert y equals x squared plus x to vertex form, we will need to divide the coefficient x, which is 1, by 2, which gives us 0.5, and 0.5 squared is 0.25. This will then become y equals brackets x plus 0.5 brackets squared minus 0.25. This is the vertex form.
Thanks for listening to part 2 of our Term 3 revision series.
Tune in next time to learn all about exponential equations.
Mr. Math Monster, out.